We've been doing a lot of trig functions with the product and quotient rule, but I think that they're important. So I'm going to do these two for this video. Hopefully we can get through them quickly. I want to do the sine times cosine one first because it seems like it'll be faster. So let's say f of theta is equal, see how they deal y equals? You have to figure out what it's a function of. There's only one variable here, so it's pretty simple. Sine theta, cosine theta. Well, these are multiplied functions of theta. So you should understand by now that we are using the product rule. We're many problems into this, and we've done a lecture on it, and I'm sure your class has hammered on it. You should see this as a product rule. Your u value, the first value is sine of theta. U prime is cosine of theta. V is cosine of theta. V prime is negative sine theta. You get this. So u prime v plus v prime u is simply cosine theta plus negative sine theta sine theta. So what do we have here? We have a cosine theta squared minus sine theta squared. And this is close to the identity, right? Remember, we know that cosine squared plus, it's a weird s, plus sine squared equals 1. Well, if I subtract the sine away twice, this can become a minus. So I think we would get this. So if you want to, we can say this is the derivative. If you want to keep it as only one trig function, which is nice, so we'll say f prime of theta equals 1 minus 2 sine squared theta, or sine of theta squared, like that. That's the answer for that one. No big deal. The next one, however, I think is deceivingly difficult. This cotangent is no easy baby. So we get f of t equals cotangent of t, and I'm going to rewrite it as e to the minus t. Why? Because I'd rather do a product rule than a quotient rule, and so would you if you've done this before. So let's think about it in this fashion, okay? Now we're going to be doing the product rule to find the derivative, u prime v plus v prime u, so let's come over here and write them out. Our u is cotangent of t, which is the same as saying cosine of theta, or excuse me, of t over sine of t. I think we're all in on this, right? So we know that. Our u prime, however, means that we need to do a quotient rule. We need to do these separately. So I'm going to make a new u, which is cosine of t, and I'm going to make a new v, which is sine of t. And u prime, negative cosine of, or sorry, that's not good, negative sine. Why did I scribble it out? Let's erase it, it'd be better. Negative sine of t, v prime, cosine of t. So the quotient rule says u prime v minus v prime u over v squared. And since we're operating in the dark gray, then we mean these, right? So u prime is negative sine t times times sine of t, yeah, that was right, minus v prime cosine of t cosine of t. And all of this is going to be over sine of t squared. And of course, if you take a minus out here, this all becomes a plus, and this becomes 1. So this is going to be cosecant of t squared. You see how I only put that in at the end? That's how you should be vibing this as well. Let's write what the v's and u's are over here since I've just got some space. Our v is e to the minus t, and our v prime is negative e to the negative t. Don't make that mistake, okay? Now we have all the u's and v's we need to do the actual product rule here. Yeah. Okay, so our u prime is the hard one, which is cosecant of t squared, v, which is e to the negative t, plus v prime, which is negative e to the negative t times u, which is cotangent of t. Let's take an e to the t out. Actually, this might just be the easiest way to do it. We'll just call it e to the negative t times cosecant of t, it's supposed to be cosecant of t squared, minus cotangent of t. And let's hope and pray, but I do believe that this is the answer to that question. So this is how you mix in the quotient and product rule into bigger trig rules.